Greetings, WolfDragon here to show you how to properly wire up your PCB version 4.X. For the purposes of this demonstration, I am using a 2-cell configuration, which just means I'm hooking up a 2-cell battery. If you want to use a 4-cell, you just hook up more wires. See the manual, it all is explained there. First bit we have to go over is the pack itself. You'll see that I have a 2-cell pack here with the main power port and the balancing tap. See here there are 3 wires for 2 cells, ground, 3.7 volts, and 7.4. Now supplied with your kit is a replacement plug, if indeed you need one to match the plug here. For mine, it uses an aligned style battery tap, which is also known as a JST XH series connector. You can see they're the same. Therefore, I will not need these 2 pieces. What I do need to see is whether or not I need to change the way this plug is wired. Just take this and plug it in, and we can see that the battery pack is reverse polarity from what I have already made for you. So to flip this around, you will go into the little locking area here, and you will push the locking feature of each pin down, and it'll come out. For this one, I'll have to do it for the most positive and ground line, as all I have to do is flip the plug around. 3-celled and 4-cell packs will require more wires to be changed. After you've bent the pins down, you'll need to bring the locking features back up away from the body of the pin and simply plug them back in, and they'll click into place. Do be careful that you do not short out these connections, as these are unfused and go straight to the core of your battery pack. And they should be holding there quite nicely. Now, the connector matches. The second step will be to take the SW link cable and the battery connector cable and figure out exactly how long they need to be for your setup. For this demonstration, I'm just going to trim the wires back and solder them directly on, so they'll look a little weird. More than likely, you'll cut down most all the wire from that. Let's see if I can do this real quick. You'll notice up in the top center of the frame is a small coil of water-soluble fluxed solder. It's what I use to put the board together. It's very good stuff and washes off either with hot water or what I prefer to use, isopropyl alcohol. The 91 or so % strength is best. The 70% will work just as well, but it takes a little more scrubbing. To make things easier, I'm going to use the spool of solder rather than the little coil. To properly tin, just get the soldering set up vertically with your soldering iron nice and hot. Simply create a pool on the tip and immerse the exposed wire into the pool. At this point, you should have stripped back approximately 3/16 to 1/4 of an inch. You will trim that down much farther when you actually install it to the PCB. The increased length just makes this job a little easier. If you notice that the wire tends to shrink back away from the solder, just push it back a little more. There's nothing wrong. So at this point, you're going to want to trim your now tinned conductors to approximately 1/10 of an inch. Anything around a 1/16 to a 1/10 will be just fine. Next thing we want to do is prepare the board itself to receive the wires. Now I have given you solder holes in each pad that you can see. However, it's much easier just to put solder on the pad and then place the wire onto the pad in a horizontal position rather than going through, as you can decrease the height of everything by not having to bend things. Which, if you want to do it, it's fine. I don't, because, well, this is easier. So we'll take the solder and go to the pads. Here I will do the ground side of the SW link cable. This will go to G on the aux port, also known as just ground or 0 volts. And I'll grab W and C. W being port 1, C being port 0. So, soldering the SW link cable on, we'll put the black wire onto G. And since everything's all nice and tinned, it should just drop into place. And it does. Bend this around over top of the LEDs. Caution line is white, so that'll go here. And the warning line is yellow. As always, after you make your solder connections, make sure that you haven't inadvertently bridged anything. I've tried to leave you plenty of space around the pads themselves, so it shouldn't be too difficult to avoid. Next, we'll solder on the battery side cables. Be sure to tin the pads as shown. Now, since this is a 2-cell pack, I've only got the 2 battery voltage wires to connect. The first one goes to B1+, which is 3.7 volts nominal. And the second one goes to B2+, which is 7.4 volts nominal. Now you can note that the B3+ and B4+ connections have not been made, and they are essentially left unconnected. The software inside of the CPU will pick up on that, and that's how it figures out what you have connected. Be sure to look at the back of the board and make sure that the pads have not had solder spilled onto others or any surrounding traces. Once you've done that, you can grab your LiPo pack and plug it in, and you will see the initial startup codes if you did this properly. Red and green will bounce back and forth. Yellow will blink the number of times that there are cells in the pack, and then it'll go green. At this point, the PCB is ready to go. It's fully booted up.